Alright, so my first question is number 5, which is a ball is thrown up into the air from an initial height of 15 meters. The ball's height above the ground is modeled by the function h at t equals negative 5t to the power of 2 plus 10t plus 15, where h is the height in meters and t is the time in seconds. So for A, the question is, determine the value of h at 1.5 and explain what these values mean in the context of the problem. So first, h, we're going to find out what the height of the ball is when we're at 1.5 seconds into the throw. So we're going to start off by filling in 1.5 where we see time in the question. So we're going to start off with h at 1.5 equals negative 5 times 1.5, so that's where the t would be, to the power of 2, plus 10 to 1.5, so that's where the t would be again, plus 15, but you just leave it like that. And then we have to start solving, so h at 1.5 equals negative 5, and then you have to do the exponent to the what's in the brackets first. So it would equal 2.25 plus 15, so that's what 10 times 1.5 is, plus another 15, which is the original. And then again, h at 1.5 equals negative 11.25, so you have to add these, multiply these together, plus 30, because you have to add these ones together. And then from that, you get h at 1.5 equals 18.75 when you add those together. And then that will give you, and then after that, you'll have to do 18.75 divided by 1.5 to get your overall time, which will then be 12.5. So overall, the ball will be 12.5 meters away from where it is originally thrown in the span of 1.5 seconds. So, and then the next question is, when does the ball hit the ground? So basically for this one, I put this in factored form to figure out the x-intercept of when it would hit. So we'll start by doing 0 equals negative 5t squared plus 10t plus 15. So this is the original equation, and then you have to break it down. So 0 again equals negative 5, and this is where you put it together. So you get t squared minus 2t minus 3, and that equals 0. And then you have to bring the 0 back over, so then again be 0 equals, and then this is where you group them. So it'd be negative 5t minus 3, bracket, t plus 1. And now this is where you bring it down to where you start getting what your answer is. So ultimately, this will equal 0 equals negative 5t plus 15, brackets, and then t plus 1 stay the same, because this, you put the negative 5 into this bracket to get negative 5t plus 15. And then after you do that, you're going to make it equal 0. So you're going to do 0 equals negative 5t to 15, because that's what you'll get ultimately at the end when you get the 15 at the end. Negative 5t plus 15. And then after you do that, you're going to want to bring the negative 15 outside, so it'll be negative 15 here equals negative 5t, because that's what we have left over. And then after you do that, you're going to want to isolate for the t. So you're going to want to divide that. So you're going to have t on the outside. And then you're going to do equals negative 15 divided by negative 5. And then this is where you get where t equals 3. And so when the ball hits the ground, it'll be 3 seconds away from when he initially threw it. And then for the last answer, which is C, which is what is the maximum height of the ball. Basically, I went off of the y-intercept, which is 15, and then the one beside it, which will demonstrate how far or high it will go, which is the 10. And so if you add those together, it'll be 25. And so the max height equals 25 meters. Thank you.